Hello and welcome to Weekly Dev Tips. I'm Steve Smith, also known as Ardalis. This is episode 7, where I'll be sharing some tips on using custom exceptions in your code. Don't forget, you can follow Weekly Dev Tips on Twitter and provide feedback or ask questions there. I'll dedicate some time to answering questions in future shows. Also, check out this episode's sponsor, DevIQ. DevIQ offers online training for software developers and designers covering topics like UX, .NET development, and my own course on ASP.NET Core. Check them out at deviq.com. So let's talk about why I prefer custom exceptions. Low-level built-in exception types don't offer very much context and tend to be much harder to diagnose than custom exceptions that can use the language of the model or application. Given the choice, you typically want to avoid throwing basic exception types like exception, application exception, or system exception from your application code. Instead, create your own exception types that inherit from system.exception. You can also catch common but difficult to diagnose exceptions like null reference exception and wrap them in your own application-specific exceptions. You should think about your application exceptions as being part of your domain model. They represent known bad states that your system can find itself in or having to deal with. You should be able to use your ubiquitous language to discuss these exceptions and their sources within the system with your non-technical domain experts and stakeholders. Let's talk about a few different examples. First, let's consider throwing too low level of exceptions. Consider that you have some code that does the following. We have a method, we'll call it calculate shipping. It returns a decimal and it takes in a string zip code. So then the first thing it's going to do is get the area from the zip code. And the area, is not the geometric area, it's the area of this location, and the shipping is tied to that area of the country, let's say. Now, if you get back a null from that get area from zip code method that you're calling inside this other method, you can't perform your shipping calculation, so you need to do something. And in this case, let's say we're going to throw an exception. So in this case, we say if area equals null, throw new exception, just the standard, root level system.exception, with a string that says unknown zip code. Now the problem with this kind of code is that client code that attempts to catch exceptions resulting from the shipping calculation are forced to catch now the generic exception instance instead of a more specific exception type. It takes very little code to create a custom exception type for application-specific exceptions like this one. You can define a class called unknownZipCodeException that inherits from exception. It could have a property called zipcode that has a getter and a private setter. And then in its constructor, it could take in a message and the zip code. And then it could use constructor chaining to talk to its base exception constructor and pass in the message. And also assign the zip code value from the constructor to the property so that if you want to inspect this exception, you can see from its property what the zip code was that was invalid or unknown. In fact, in many cases, you can go a step further than this. You can create an overload, another overload of the constructor, that sets a standard default error message so that you're consistent and your code is more expressive with fewer magic strings in your code. For example, you could add an overload that also is for the unknown zip code exception, but instead of taking in both a message and a zip code, it could take in just the zip code, and then it could pass into the other constructor the standard exception message that you want to use. For instance, a string that says unknown zip code. This will make it so that you won't have to pass as many parameters in your code, and you won't have to specify the exception message again and again and again, although in this case perhaps you're only doing it typically in one place. But it will keep your code drier. It will have less repetition, dry being don't repeat yourself, and it'll make it easier for you to maintain, and if you need to, easier to localize that exception message because it's only in the one location. Now the original code that dealt with calculating shipping can go and get the area from its method, and then if that area is null, instead of throwing an exception, it will throw a new unknown zip code exception and just pass in the zip code that it was trying to find. Any client code that is working with this operation can now have a specific catch block that will handle the unknown zip code exception type, resulting in a more robust and intuitive design. Another approach that you can take is to replace framework exceptions that are thrown that perhaps you don't have any control over with your own custom exceptions. An easy way to make your software easier to work with, both for your users and for developers, is to use higher level custom exceptions instead of low level exceptions that may occur. Low level exceptions like null reference exception should rarely be returned from business level classes where most of your custom logic should reside. By using custom exceptions, you can make it much more clear to everybody involved what the actual problem is. You're working at a higher abstraction level using the language of the business domain. For example, let's say you're writing an application that works with a database. Perhaps it's an ASP.NET Core application in the medical or insurance industry, and it references individual customers as subjects with a capital S. Within some business logic dedicated to creating an invoice, recording a prescription, or maybe filing a claim, there's a reference to the subject ID that is invalid. When your data layer makes the request and returns from the database, the result is null. So imagine you have some code that says var subject equals get subject, pass in subject ID. That might return null if that subject ID does not exist in the database. Obviously, in the code I just described, if the subject is null, then the next line, which might be subject.do something, is going to throw an exception. You can avoid this by using the null object pattern, which you'll find a link to in the show notes. But let's continue on and assume that we're just getting back a null. Now let's further assume that we can't handle this exception here. If the subject ID is incorrect, there's nothing else this method can do but throw an exception, since it was going to return the subject otherwise. The current behavior for a user, tester, or developer is something like this. They're going to see a message that says unhandled exception, system.nullReferenceException, object reference not set to an instance of an object. If you've been coding for more than a few days, you've probably run into one of these exceptions in your experience. Now, one of the most annoying things about the null reference exception is that it is so very vague. It never actually specifies which reference exactly was not set to an instance of an object. In our scenario, it's pretty clear, but in many cases, it's not as obvious. This can make debugging or reporting problems much more difficult. In the above example, we're not specifically throwing any exception, but we are allowing a null reference exception to be thrown in the event that we're unsuccessful in looking up a subject for a given ID. It's still a part of our design to rely on null reference exception, though in this case it's implicit. What if instead of returning null from getSubject, we were to throw a subject-not-found exception? Or if we weren't sure that an exception made sense in every scenario, what if we checked for null here, where we're calling that method, and then threw a better exception before moving on to work with the returned subject? Perhaps we could have a subject-not-found exception that we would throw in the case where the returned subject was null. So our updated code would say something like var subject equals get subject, pass in subject ID. The next line would be if subject double equals null, throw new subject not found exception, pass in the subject ID that we just used to try and find that subject. If that statement passes, then move on to the code that works with subject and call subject.doSomething. You'll find these code snippets in the show notes as well. If we don't follow this approach and instead we let the null reference exception propagate up the stack, it's likely, if the application doesn't just show a yellow screen of death or some default oops we failed page, it's likely that we will try to catch null reference exception and inform the user of what might be the problem. But by then we might be so far removed from where the exception occurred that we may not even know for sure what might have been null and resulted in this exception being thrown. It's also very possible that this exception might be thrown in the middle of a long multi-line link statement or object initializer, making it more difficult to know what exactly was null. Raising a more specific, higher level exception makes our own exception handlers much easier to write. So how do you write your own custom exceptions? As I described earlier, it's very easy to write a custom exception for the case where no subject exists for a given subject ID. You should name your custom exception something very specific, and they should end with an exception suffix. In this case, we're using the subject does not exist exception or subject not found exception, whatever makes more sense to you. You can create a class that inherits from exception, system.exception, and then use constructor chaining to pass in some information to the base exception constructor. There's some example code on the site, but essentially in your constructor, you can follow the constructor line before your curly braces with a colon, and then the keyword base, and then pass in any arguments to the base constructor at that point. So you can have an empty constructor that maybe takes in some details like subject ID, and then call the base, which in this case is going to be system.exceptions constructor, and it has a constructor that takes just a string for the exception message. So you could construct the exception message right there and give it something like subject with ID, subject ID does not exist, and use string interpolation to insert the subject ID into that string so that when the exception is thrown, you'll see the appropriate exception message. Again, you'll see these code samples in the show notes at www.weeklydevtips.com/007, just like James Bond, 007. Now, in the example I just mentioned, with no error handling in place, the user will get a message stating subject with ID 123 does not exist, which is much better than object reference not set to an instance of an object. It's far more useful for debugging or reporting purposes. In general, you should avoid putting custom logic into your custom exceptions. In most scenarios, custom exceptions should consist only of a class definition and one or more constructors that chain to the base exception constructor. If you follow domain-driven design principles, I recommend placing most of your business logic related exceptions in your core project within your domain model. You should be able to easily unit test that these exceptions are thrown when you expect them to be from your entities and services. That's it for this week. Thanks for listening. Please consider leaving a review on iTunes, Stitcher, or wherever you found this podcast, and we'll see you next time on weeklydevtips.com.